Hello, in this video, I explain how the universe works. I explain the cycle of matter, the how black holes work within the cycle of matter, the explosion of black holes into Big Bang at maximum temperature. I introduce a new physics reaction, which is the fhlip, nuclear fhlip. It will allow us to do flip bombs, planet busters. So this is what you will learn in this video. First, the cycle of matter. The sun gathers the gas from its surrounding. The mass of the bubble increases to a point where it enters nuclear fusion, which means two hydrogen come together into an helium, and after that helium comes together with hydrogen to form lithium. That's fusion, and it gives out energy until the atom has a medium mass. You cannot do fusion on medium mass atom into heavy mass atom because it does not give energy, it takes energy. So the sun takes light atoms and make them medium weight. The black holes explode, eventually returning all the matters to light and eventually hydrogen. That's the cycle of matter. The sun is in a galaxy called the Milky Way. Turn around in 226 million years within our neighborhood. The black hole in the middle of our galaxy is called a Sagittarius. It weighs about 4 million sun, which is not much, because the sun in the solar system has the big part of the mass of the solar system, but within the galaxy Milky Way, our black hole is a small fraction of the mass of the galaxy. The galaxy has more than 200 billion suns, so 4 million sun is a little bit. The black hole is like a sun that has gathered more mass up to a point where the gravitation is so strong that the light cannot go out anymore. It's at the middle of the galaxy. It eats the sun systems, solar system, which are nearby, and it increases its mass all the time. Eventually, it comes to a point where it blows up. That blowing up, I believe it happens when it has reached maximum temperature. Maximum temperature is a concept that was introduced by Max Planck, and I will explain here how it works. First, when the black hole increases mass, it increases its internal temperature, because mass and internal temperature are related. Planck has said that too. And eventually it comes to a point where it blows up in what I call a Big Bang. I think that there has been many Big Bangs. Big Bangs happen here and then. There was a Big Bang nearby 15 billion years ago, but it was not the first Big Bang, I believe, and it is not the last Big Bang. When a Big Bang happens, the black hole expands into a first light, then hydrogen cloud. That hydrogen cloud is expanding within an existing galaxy. And when it hits stars growing up, when the cloud goes up, it meets solar system, it goes turning like that. And when it turns the cloud, it's a good start for a new solar system. So the other thing is that when a black hole blows up, there is a big energy impact on solar system nearby that were about to be eaten by the black hole. That big energy impact could explain the creation of the heavy atoms. Like if you take medium weight atoms, you cannot fusion them without energy. That Big Bang could provide the energy to create the heavy atoms in the solar system nearby the exploding black hole. The other possibility is that the explosion of the black hole is not perfect. Black holes crunch all the atoms, and if it's not a full matter to energy conversion, there could be some matter that is spread around, and that matter could be atoms of all weights, like light, medium, heavy, or very heavy, with short half-life. So there is two ways to produce the heavy atom, which is either an imperfect Big Bang or the impact of a Big Bang on nearby solar system. Now I will speak about that maximum temperature. Max Planck have said that there is a maximum temperature, but they didn't say what happened. So what I tell you is that what's happening is that matter changed to energy at that point. It's a third physical reaction. We know the fission of heavy atoms into medium weight atoms, like we take uranium and plutonium and we split them in two. That's nuclear fission. We can take light atoms like hydrogen, deuterium, and put them together into helium. That's called fusion. We put them together. That frees energy too. Now there is a third nuclear reaction. It's the flip. The flip takes mass atoms and flips it into energy. It's not a differential energy. Like fusion would change two hydrogen to one helium and would free the differential energy, because helium is more stable than hydrogen. When you fusion them, there is energy release, but it's a differential between two states of matter. And when you take one heavy atom and you split it in two medium weight atoms, it's also a differential, because two medium weight atoms are more stable than one heavy weight atom, and there is energy release. But in both cases, the energy release is because of a differential between atomic weight. But with the flip, it's really changing the mass into energy. It's not a differential, it's a full transformation of the mass into energy. That's happened at maximum temperature. People would say there is no way to have a maximum temperature because you can always push energy into matter. What happens if you keep on pushing energy into matter? Once that's reached maximum temperature, if you just put more heat in it, what happens? What happens is that the matter flips into energy, so there is no more matter to heat. When you think if you put energy into matter, it must heat more? No, because there is no more matter. At some temperature point, matter flips into energy. So Planck have told you that there is a maximum temperature. It didn't tell you what happens. Now I'm telling you what is happening. What happens at maximum temperature is that matter flips into energy. And that is what happened in black holes when they have reached that mass that put them at maximum temperature. They blow up in big bangs. So that nuclear reaction, I call it the phlip. P-H-L-I-P. It's like the flip with an F, which is used for a flip-flop, which is a two-state, because it's like two states between matter and energy. So that's the flip. Matter flips into energy. So the opportunity of a flip bomb. The flip reaction frees a lot, gives a lot of energy, so there would be an opportunity to build planet busters nuclear weapons. I guess that it will be soon available to humanity. To better understand the maximum temperature, I will explain to you how I found out about all that thing. It's not studying Planck or studying my own model, and then I made a link with Planck maximum temperature. Then things became clear. But my model was something else. I was thinking about the electron and the proton, like always wanting to meet and never being able to, because I was thinking the electron was falling on the proton, not like Rutherford. Rutherford says the electron turns around. And I was thinking the electron falls on the proton, but it goes through, and the proton expands toward the electron, but it goes through. And once they have passed each other, they just turn around and come back. It's always like that all their lives. That's an atom in my model, electron and proton. It's like two spheres, electric field is more like a football, and magnetic fields a bit more like that. And I was studying my model. There are other things that atoms radiate energy. When you want to know the temperature of somebody with a contactless thermometer, the thermometer looks at the color of the temperature of the person. The heat of the body is in infrared. It's not red, it's infrared. If it was red, you would look how red it is. Now you look how infrared it is. Your eyes cannot see infrared, but the thermometer can see infrared. And the warmer, if somebody does fever, the temperature will be higher, the wavelength of the temperature will be shorter, and the thermometer, contactless thermometer, would evaluate the wavelength, and after that it would evaluate the temperature of the person with fever. For example, here that's a wave. The distance between two tops is the wavelength. When it heats up, the wavelength becomes shorter. When an atom or a radiating body becomes hotter, the radiated wavelength becomes shorter. For us in our environment, the wavelength is usually very much bigger than the radiating body itself. But when we go to the maximum temperature, the wavelength becomes as short as the radiating object itself. When the wavelength has become as short as the radiating body gives itself the wave. That's at that point that the mass becomes energy. I'm telling you in my model the same thing as Max Planck told you with his maths about maximum temperature. He said it in mathematical formula, and I'm telling you into my model, the minimum wavelength happens at one temperature, and that temperature is that maximum temperature, and it's the temperature at which the wavelength is the same as the radiating object, or half the wavelength, something like that. It's the same size of the radiating object. At that point, matters become energy. Big Bang. So that's what happens. A black hole smashes all the atoms together and behave like a very massive single atom because it's a single radiating object. Usually an atom is a radiating object, but black holes are by themselves radiating objects. It's like supermassive atoms. All the Rutherford would have said all the proton together and all the electron, but the model is different. But the thing is that the black hole is a single radiating object. It has its maximum temperature. Once it has reached the maximum temperature, it blows up into a Big Bang, and it recycles all that mass into light, which will become hydrogen and start over the cycle of matter. So this is it. When I do a video like this one, I put it on YouTube, but not public. I give the link to outreach at Department of Energy, and if they don't want me to make it public, they tell me, and if they have no objection, I put it public after 1 week.